Welcome to Get Your FRQ On. This question is from the 2017 AB exam. It's question number 5. It is not calculator active. In the question stem, we're told about two particles P and Q moving along the x-axis. We are given a function x of t that describes the position of particle P, and we are given another function v of t, which gives us the velocity of particle Q at time t. In part 1 of the question, or part A, we are asked to find all values of t between 0 and 8 when the particle P is moving to the left. In order to be considered moving to the left, the velocity of particle P would need to be negative because we have the position of particle P. In order to determine its velocity, we have to find the derivative x prime of P of t and determine when that will be less than 0. All right, so we take our function xp of t and we differentiate it, and we get 2 times t minus 1 all over t squared minus 2t plus 10. Now, in order for this to be negative, we have to determine the sign of both the numerator and the denominator, since a positive divided by a negative or a positive divided by a positive, several things could happen. All right, now, because of the numerator, we know that the function x prime p of t is going to equal 0 when t is equal to 1. But the denominator, t squared minus 2t plus 10, doesn't have any real zeros, and it's oriented up, so the entire graph of t squared minus 2t plus 10 would be above the x-axis, indicating that the denominator of x prime p of t is never negative and never 0. So we only really need to worry about the numerator. All right, so solving x prime p of t is less than 0, we can see that x prime p of t is equal to 0 when t is equal to 1, and that t squared minus 2t plus 10 is greater than 0 for all values of t. All right, from this, we conclude that x prime p of t will be less than 0, and therefore particle P will be moving to the left whenever t is between 0 and 1. For part B of this question, we are asked to find all values of t between 0 and 8 for which the particles move in the same direction. Now, because it doesn't specify which direction, we really don't need to know when they're both positive or both negative. We just need to know when they have the same sign. Right? So in order for the two particles to be moving in the same direction, x prime p of t, which we already found, and vq of t, which is given in the question stem, must have the same sign. They don't have to have the same value, but they do have to have the same sign. Right? We've already seen that x prime p of t is negative when t is between 0 and 1, and positive when t is between 1 and 8. Right? The velocity function for q, t squared minus 8t plus 15, that's factorable. That's t minus 3 times t minus 5. And since the leading coefficient is positive for vq of t, we know that this parabola would open up, and therefore vq of t would be negative between 3 and 5 and positive elsewhere. All right, so combining this, just trying to match up equivalent signs, x prime p of t and vq of t have the same sign when t is between 1 and 3 and when t is between 5 and 8. So on those intervals, the two particles p and q would be moving in the same direction. In part C of the question, we are asked to find the acceleration of particle q at time t equals 2 and determine if the speed is increasing, decreasing, or neither at t equals 2, and to provide an explanation. Well, the acceleration of particle q at time t equals 2 would just be v prime q of 2. All right, so we need to find v prime q of t and then evaluate it at 2. So v prime q of 2. Well, we can differentiate vq of t. That's just going to be 2t minus 8. So if I evaluate this at t equals 2, we're going to get v prime q of 2 equals negative 4. Right? So the acceleration of particle q at time t equals 2 is negative 4. However, the speed of particle q is going to be increasing at t equals 2 if vq of 2 and v prime q of 2 have the same sign, and decreasing if they have opposite signs. So we have to check what is v of 2. We already know v prime q of 2 is negative. What is the sign of vq of 2? Right, so we can evaluate vq of 2 pretty easily. That's just 2 squared minus 8 times 2 plus 15. It equals positive 3. And what's important here is that that 3 is greater than 0. So what we've determined here is that vq of 2 and v prime q of 2 have opposite signs, and that's what we use to conclude that the speed of particle q is decreasing at time t equal 2. So because v prime q of 2 and vq of 2 have different signs, the speed is decreasing, regardless of which direction it's going in. In part D of this question, we are asked to find the position of particle q the first time it changes direction. Right, so we have to do a couple of things here. We have to figure out when is the first time particle q changes direction, and then we have to find the position of particle q at that time. So particle q is first going to change direction when vq of t is equal to 0 for the very first time. Right? Given what vq of t is, we've already factored it in a previous part of this question. We know that the first time vq of t is equal to 0 is at t equals 3. Right? By the fundamental theorem of calculus, we can use the position of particle q somewhere else in this time interval and definite integration to evaluate and figure out the position of the particle at t equals 3. All right, so xq of 3, which would be the position along the x-axis of particle q at t equals 3 seconds, would be xq of 0 plus the integral from 0 to 3 of v of q of vq of t dt. And we're given in the question stem that the position of particle q at t equals 0 is 5. So we just have to take 5 plus the definite integral from 0 to 3 of vq of t dt. Well, vq of t is a polynomial, so we can just use the general power rule to come up with an antiderivative for vq of t, which would be the xq of t function. Right? Remember, the derivative of position is velocity, so the antiderivative of velocity is position, and we evaluate the definite integral. So we find the antiderivative, we evaluate the definite integral, we add the original 5 to it from xq of 0 equaling 5, and eventually we can see that the particle's position, particle q, at time t equals 3 is 23.